What's up, curious young people? Every day we use different objects, and many times we don't really know how they work. From a simple blender to the mechanism behind a Glock pistol, we can investigate how everything works. For all that and more, here are 7 things you didn't know how they worked. Chainsaw. When it comes to cutting down a tree, we could spend several hours using something more conventional like an axe. Or we could use a chainsaw that allows us to cut through thick logs of wood like a hot knife through butter. If we open up the chainsaw, we'll find hundreds of different parts that work together to make relentless cuts possible in just seconds. The first thing we have is a small but powerful engine, where we find a piston that, fueled by gasoline, will move and produce power just like car engines do. In this part of the engine, we also have the crankshaft, which transfers the engine's movement to the chain, allowing it to spin at over 110 kilometers per hour. If we look at the chain, we see that it is made up of 3 layers, the 2 outer ones, where the sharp teeth are, and in the middle there is a link that only serves as part of the chain's structure. Still, the key to the chainsaw being able to cut through everything in its path isn't the sharp teeth, but rather the metal bar that guides the chain along its entire path. A guide that has to be tough enough to withstand all the pressure on the chain, and at the same time light enough so it doesn't wear out our lumberjack's arms. And last but not least, there are the safety measures. On one hand, we have the safety handle, which is connected by a band to the chain bearing, so when we stop pressing it and let go, everything stops in less than a second. And to solve the problem of the machine's vibrations, which in the long run can hurt our hands, there are a series of springs inside the machine that are designed to reduce the vibration that reaches our hands. Glock pistol. In the world we live in, there are weapons, and without a doubt, one of the most famous is the Glock pistol. This pistol became the most widely used in the world since most police forces trusted this Austrian model, which has been improved from time to time to offer the best possible pistol. But do you know how it works? The first step is to insert the magazine, which, depending on the model, can hold between 15 and 17 rounds. Now, once we want to shoot, the trigger is pulled back, which releases a safety and causes the firing pin to move forward and strike the projectile at the rear of the primer. All of this creates an explosion, releasing hot gases that propel the projectile through the barrel. A barrel that has an interior design intended for the projectile to spin, giving it greater stability. Once the first shot is fired, the recoil force acts on the springs and causes the slide of the weapon with the firing pin to move backward, achieving 2 things. First, the casing of the recently fired projectile is ejected from the pistol. And now, when the whole mechanism moves forward again, it pushes the new projectile and leaves it ready in the chamber to pull the trigger again. As we can see, pistols are so complex and at the same time so easy to use that, for example in this case, they need to have 3 different safeties on the weapon to prevent anyone from firing it. 1 safety on the trigger and 2 others that act on the firing pin. Stay away from guns, Timmy. Fishing rod. If you like fishing, then you know that the rod can become your best friend or your enemy if it doesn't work the way you want. Even though this seems like a simple invention, there's advanced technology behind it that lets us reach long distances, handle big fish, and have something both light and strong in our hands. If we open the rod, we find more than 150 components all perfectly placed, because even the slightest failure would jam the whole system. On one hand, we have a reel loaded with 500 meters of specially braided line, ready to cast far. After this, we have a stainless steel ball bearing that allows the reel to spin 10,000 times per minute, something that can be fully utilized with the handle to retrieve the line with our huge catch hooked on the hook. It's very interesting that in those more expensive or complex rods inside the frame, we can find a brake disc made of carbon fiber, which is designed to control the speed at which the reel moves. So then if the rod is very good, maybe we'll have the option to adjust this brake so it takes more or less force to reel in the fish. Digital jukebox. An invention that undoubtedly revolutionized restaurants and bars in the 1950s in the United States. And even though today we have all digital music, The unique sound and technology used by the jukebox fascinated more than one person. Inside a digital jukebox, we find a wooden cabinet that houses more than 1,000 components all working together. The vinyl records, which in this case are CDs, are picked up by an aluminum hook that gently grabs them and places them in the player with millimetric precision, so the system can work perfectly. Below this, we find a series of powerful speakers that will make the whole room vibrate. 5 speakers made up of membranes and a set of magnets that together amplify the sound waves without distorting them. But even with a digital sensor to make the discs sound like they're from the 1950s, a wooden cabinet is used to create that retro effect and make a digital jukebox sound almost like an original one. Inside the jukebox, we have a small but powerful motor that, through a chain, moves the robotic arm responsible for picking up the disc we've selected. Then, with a vertical movement, the arm grabs the CD directly and places it onto the player. And the reason it can keep moving for years and years is because behind its construction, there are thousands of different parts that were put together by the right people. And finally, we can't forget that a good jukebox must have its unique bubble system and lights, which are achieved with glass tubes filled with a very special chemical that boils at low temperatures and creates those satisfying bubbles. That's really interesting, my friend. Car wash. If you have a car, then you know that every so often you have to wash it, at least on the outside. Not only so it looks good, but also so that substances like bird droppings don't damage your paint. Well, in this case, if we stop to look at how an automatic car wash works, we find the following. To be able to wash the car without any problems, we have a real feat of engineering. The first stage of the car wash is an impressive chain that pulls the cars through all the areas at a good pace, giving us a clean car in less than 3 minutes. A chain that can handle 30 tons of weight or more than 5 cars at the same time, working with a hydraulic motor that moves the cars using high-pressure oil. After this, the next step is to brush or scrub the car. In this case, we have these giant brushes that are specially designed to clean every corner of our car. In addition, the mechanical arms that hold them have minimal resistance, which allows the brush to adapt to the shape of the car and move as needed, letting us wash all kinds of vehicles. Then, high-pressure water jets take care of rinsing off all the soap, so we can finally move on to the drying section, where powerful turbines turn on to suck in the surrounding air. And, just like a tornado, it concentrates the air in the middle, then expels it at over 300 kilometers per hour onto our beloved and delicate car. Blender. If you like fruit and smoothies, then you probably have an interesting blender at home. But did you know how it works? Even though it may seem basic and simple, a blender needs a lot of power to do everything it does, and there's a lot of technology behind it. When it comes to blending fruits, it doesn't require much, but to pulverize nuts or ice, which are as hard as rocks, we need more than 140 components working together harmoniously to blend everything in just a few seconds. Inside the blender, we find a powerful motor of about 1,800 watts, which can even be more powerful than the engines of some small motorcycles. In the jar, we have a blade that, although not sharp at all, doesn't cut but rather pulverizes the food through a delicate system of bearings and a metal structure, which allows it to spin at tornado-like speed to blend everything it touches. It's interesting to know that the jars are not just simple containers, but some brands spend years and years designing the best possible jar to blend as efficiently as possible. For example, in this case, we have a 5-sided jar designed to prevent the formation of whirlpools, making everything blend better. When we look at the motor, we find an electric motor covered by more than 60 metal plates, welded together and wrapped with about 90 meters of copper. This powerful motor will be able to spin at thousands of revolutions per minute, even spinning faster than the turbines of some airplanes. So once we press the right button, everything turns on and starts spinning, so the blade can pulverize anything it touches, spinning at over 300 kilometers per hour. Locomotive. Although nowadays we mostly see electric trains, or even magnetic trains in some very advanced countries, for many years Most trains ran thanks to steam locomotives. And did you know how they work? The discovery of steam engines was a turning point in history, because among the things they made possible was keeping a vehicle like a train moving continuously. And if we look at how a locomotive works, we find the following. The first thing we have is a huge boiler, which is going to be fueled by coal or any type of fuel. All that flame will generate intense heat, which, along with the smoke passing through a series of pipes, will heat a water tank to the boiling point. At that moment, the high-pressure steam filters through a series of pipes, passing through the classic valve, which, if activated, will release the steam outside, making the famous steam sound. And finally, this hot gas travels through the pipes until it reaches a series of pistons that, due to their interesting design, end up moving some of the locomotive's wheels, while the rest follow along with the main movement. Before leaving, I'll greet everyone who comments here and on the secondary channels. A big shout out to Kevin Figueroa, another greeting to Loudy Farfan, and a greeting to Leonardo Ariza. Then I'll send a greeting to Lionel Villalta, another one to Leto Adan, and the last greeting goes to the awesome Magda and Andres.